Hey there. My name's Sam. I'm a security engineer at Airbnb, and I've been thinking for a long time, just in the back of my head, if I were going to write some malware, like what would I want to do with it, and what would my focus be? So I'm not a typical security researcher. I came up as a Mac admin, and now I'm a security engineer. So maybe I have a little bit of a different focus or background than other people here. But I kind of thought that the most interesting things that you could do today with malware would kind of to do with root. So, like a little history of root on macOS. Like in the beginning, there was root, and there was nothing more powerful than root. Root could do anything that it wanted to on the Mac, and that was just it for like the first 10, 11 years of OS X and into macOS. But Apple's kind of figured out that root has been more powerful than it probably should have been. And a few years ago, they came out with system integrity protection. This is a few other features like requiring code signing for texts, but really the implications for malware aren't that much. All SIP really does, in my mind, is just like keeps you from deleting chess. And this might matter to you if you're like a huge organization that doesn't trust your employees to ever do work because they're just going to play chess all day. But I don't think for malware, SIP really matters that much. So in Mojave, Apple came out with TCC, Transparent Consent and Control. And this is really about protecting user data from applications that shouldn't have access to it. And I think that this does have real implications for malware, but not the kind of malware that I would want to write. So what does TCC do? It really just protects files on the disk and directories so that applications that aren't authorized to read them can't read them. So in this case, if you're root, you can't read the iMessage database of a user. That's kind of unfortunate. We can't see that data anymore, but whatever, we'll write our malware to do something else. So what I've really just thought about is it rootless or rootless? Like, what does the less really mean in here? And at this point, we're in root that can do less, but root is still there. So it can do a lot of interesting things. And like on many systems, it's just yours for the taking. So let's kind of talk about that. But like, what can root still do that's interesting in the case of malware? So we can install launch daemons to persist. That's pretty simple. We can modify, insert trusted roots so that we can intercept software. We can block communication with your MDM either by removing the profile if it's not DEP, or just blocking it through the PF firewall, or just modifying the host file. We can still do that. We can unload all those security tools that are going to protect you from malware. So whether that's the launch daemons or unloading the text, we can't load any new texts that aren't whitelisted, but we can unload them. So that's nice. We can install authorization plugins to get the user's password and then grab their keychain and upload them somewhere and get all their passwords. I really don't understand why authorization plugins are still permitted. Maybe that'll change tomorrow, but we'll see. We could enable file vault too. Like, this is great for if we wanted to write a crypto locker. And there's like so much more that we could do. And it's not really hard for malware to get root on something. Like, you can really just ask for it, and most users are probably just going to give it to you. But what if we didn't have to ask for it? Let's like root without user authentication. That would be really great in the case of malware, because these pop-ups, they're a little sketchy, and people forget their passwords, or maybe they're not admin. And probably some user, if you're in a large organization and you're targeted with this kind of malware, Someone's going to notice that and say something. But let's do it without that. Now, root escalations have been in macOS for a long time, and people still focus on them. Here's a vulnerability earlier this year in Feedback Assistant where it would run executables that may have been writable by other users, and it was a simple root escalation. And that's cool because it's built into macOS, and oops, and like this is what a Mac looks like out of the box. But I don't know anybody's Mac that actually looks like that. Most people's Macs kind of look like this, and they have like all this stuff on them. They've got applications and applications and more applications, and it just goes on and on and on. And this third-party software is just like bad. You probably shouldn't trust third-party software with root because you don't really know what they're going to do with it. It's like you just shouldn't trust third-party software with root without fully analyzing what it's doing to your system. So let's talk about some examples of where these vulnerabilities might be. So here's an application which I discovered was vulnerable to, vulnerable to root escalations by having permissions being bad. So this is an application which you drag and drop to your applications folder. And as we know, for the last few releases of macOS, users have the ability to install applications to the applications folder without authorization. They have write access to it. They can do that. They're going to drag and drop it, and no authorization dialog is ever going to pop up. So they do that. They follow the instructions, and they right-click it and click open because this is not code signed, because that's really hard to do. And you open it up, and you get this dialog, and it asks you to type your password in, and it installs a launch daemon. So the launch daemon that it installs looks like this, and it points to an executable that's inside of that inside the application bundle. And that's fine, except on modern versions of macOS, that file is going to be writable by the user. So malware could just come along and change that file, and the next time launch daemon initializes, it's going to run that as root. So pretty simple root escalation. These are extremely common in drag and drop applications. So if you ever drag and drop an application in your applications folder and it pops up a authorization dialog, you should probably question what it's actually doing. But maybe we should talk about something that's more common than this non-code signed application that does this. Like, I would hope that most people in this room would kind of question, this non-code signed app that then pops up an authorization dialog. Like, that something is kind of sketchy. It had a sketchy looking disk image. So something more common than that. So I'm going to guess that most people here use Homebrew. Now, Homebrew is a great tool if you want to install, Python 3 or other programs that don't come on your Mac. And I'm sure that Homebrew sells a lot of Macs to a lot of developers. But it didn't really treat root with the respect that it needed. So a lot of formulas in Homebrew that you install require you to use sudo to start the service for the program that gets installed. So in this case, DNS mask needs to bind to a lower number port, so it needs to run as root. And normally you don't run Homebrew with sudo, it needs to elevate during its installation, but normally, even if you run root as root, it'll warn you like, hey, don't do this. But sometimes it needs to do that. So in this case, we installed DNS mask and then we started the service, and it's running, and that's great. But if we look here, that DNS mask file is owned by my user and not by root. Now, Homebrew attempted to solve for this problem by making DNS mask not writable. So if we look at the DNS mask file, we only have read and execute permissions on it, and not write. So like that's an attempt, and we can't write to that file without changing anything. But we still own the directory. We can still change that file. So in this example, I just wanted to abuse that I made a simple script and simple evil script that would just create a file in the library, which only root can write to. So we can't change the file, but we can rename it. And so I renamed it and moved my evil executable into the same place. This is all just running as my user. And then the next time you reboot, our evil script will run. So I reported this to Homebrew a few weeks ago, and it's been fixed since then for Homebrew services. And now whenever you start a service, it gets through Homebrew. It gets owned by root, and the sticky bit gets set so non-root users cannot change or modify them. But like, what else is vulnerable to this kind of attack? There's a lot of things. Now, I can't say what is vulnerable to this. First of all, because I don't know everything that's vulnerable to this. There's so many things. But also, this is the number, what is this? 9 big popular applications, including Mac management tools, like enterprise communication tools, even some Mac security tools are vulnerable to these types of attacks because they don't place the right permissions onto the executables that they install, whether through launch daemons directly or through root processes, like things that we can tamper with. But I'll show. So I can't tell you everything that is vulnerable to this because, of course, I don't know. But also, a lot of them haven't been fixed yet. I've reported to a lot of vendors about this. Some are taking months to fix it. Others dispute that this is actually a problem. And other things only happen when you have combinations of different software. So I just wanted to show a demo of what this looks like, of what my demo malware would look like. I want to close that. So I've got a VM over here. I cannot see that super well. This is the hard part. Okay. So I've got a VM here, and I developed this silly malware that I call root Canal, and I already downloaded it here. And we can see that I have it notarized because I don't know what notarization actually checks for, but I wasn't able to get it to reject anything that I wrote. So here's my silly application. I spent about 5 minutes in Interface Builder. You can like play with all these things, whatever. There's like buttons you can click. I don't know. But when you click this button here, you end up with this like objective by the C root CA trusted in your system keychain. And like, what actually happens when I click that button? So it's scanning the file system for launch daemons well, it loads all launch daemons into memory to figure out what they run. It scans all the executables that those run, and it will prioritize anything that has a watch path that can be written to. So watch paths are probably my favorite feature of launch daemons because you can make things run just right now. So if it finds one that has a watch path that it can touch, it will touch that and it'll run immediately. Now, if there aren't any with watch paths, it will still do this, but you have to wait for the service to relaunch, whether that's to reboot or otherwise. Thankfully, I found one that used the watch path because then this demo was way faster because rebooting on VMware takes forever. But that's really it. I did give it a nice feature where if you click it again, it will remove the root, but there's a, I don't know why in keychain access. It will live show it in there, but when it disappears, you have to reload the app or whatever. So that's like the example malware that I wrote. I could obviously have it do way more than that, but I didn't want to like crypto lock my own machine. So back to this. This is so confusing. So that's the demo of this silly malware. It's like it really scans for everything. I can't tell you what is installed in that VM. There's a lot of third-party software installed in that VM. They're very easily reproducible. But really, this is like about your disk permissions. And you know, Apple removed this repair disk permissions thing, but you've got to repair your disk permissions if you're going to use this third-party software. Like applications have to repair disk permissions, and it's not just drag and drop applications or like homebrew services. Applications that install through packages can be very vulnerable to this kind of thing as well. Whether that's because in their BOM they specify things being owned by groups that everybody is in instead of real, or they have crazy post-install scripts that change everything that got installed in the right way. So what I would strongly recommend is if you're going to install things from packages that have any post-install scripts, install it on another machine and then analyze what it actually ended up as. Because I've seen installers that have like hundreds of post-install scripts and you don't really know what they're doing. But how can we tell what is actually vulnerable to this, and how did I find it? And how did I find all these vulnerabilities? So at Airbnb, we use a tool called OS which is originated out of Facebook. And it's a great way to look at what's actually on your system and like look at, you can, because of its SQL interface, you can like join against different tables and look at different conditions of different things. So I like to write somewhat complex SQL queries that we use in OS Query. And don't worry, I'll share these out later. But what this one does is looks at all the launch daemons in your system. Oh no, this one looks for root processes there, scrambled around. So this looks at all the processes that are running as root and all the and the files that are backing them, and whether or not they're actually owned by root or owned by wheel. Like, can they be written? They might even be owned by root and wheel, but they might be writable by some other user. So this helps us find vulnerable applications and executables. And it's not just the things that are directly referenced by launch daemons, but it's things that they may invoke later on. Now, one of the hard things with launch daemons is that it's very hard to tell what's actually going to get executed. So this is this is an example launching in from Monkey. It's not vulnerable to this type of attack, although it could be if someone like schmodded user local recursively like 777, then it would obviously be vulnerable. But here you have user local monkey supervisor. Like, it's easy to tell that that's going to be executed, but later you have a parameter of this managed software update executable, but it's just a string. You don't really know, like, when you're looking at thousands of launch daemons, like, what's actually going to get executed. So that's why it's really important to look at the actual processes that get executed. Oh, this is the same exact query. I will share out the direct queries, but the point here is that OS query makes it really easy to find these types of vulnerabilities. And when you look at the launch daemon ones and processes too, this doesn't tell you the whole story. So here's an example of something that would get returned from OS query. It's from Carbon Copy Cloner. And we can see that this executable is owned by my user and it's getting run by root. And I attempted to replace the executables here, but it's not actually vulnerable to this type of attack because Carbon Copy Cloner verifies the executables that it's going to execute as root before it actually runs them. So just because something gets returned through one of these queries doesn't mean that it's actually vulnerable. So how can you minimize like your companies or your direct exposure to this kind of thing? As well as if you're a developer. Obviously, evaluate the state of things after you install things. Keep user local bin out of your path. Like, it's really popular to use Homebrew, and I think Homebrew effectively owns this path these days. But it's easy to swap binaries into there. If you're a developer and you want your program to end up in user paths so they can easily run it, use this feature of macOS called etcpaths.d. You can create a file in this folder and it will end up, and the contents of that file will end up in user paths without you having to dump your executables into user local bin or somewhere else. Tools like Monkey and Puppet use this, and it works out pretty well. If you have management tools that call out to other executables, whether that's like if you're using Factor with Puppet or you're using like extension attributes in Jamf or whatever you're doing, use full paths to executables, the ones that ship on the system, instead of just saying curl, or use like user bin curl. Use the things that Apple gives you, so you're less susceptible to having things swapped out on you. And follow up with OS query. You can use process events even to know kind of what's vulnerable to this. But the real winning move here is just assume that any non-sandbox process can run code as root on a real Mac. As much as you can do to guard against this kind of thing, without doing crazy full static analysis of everything that's going to run on your computer, it's hard to know whether something might be conditionally executed or something like that. So yeah, just assume that. And like, what could Apple do to help us with this? The things that we found most common were directly vulnerable processes through LaunchD. So it would be great if LaunchD wouldn't execute directly programs that don't have safe permissions. I don't think this will change because it's been the behavior forever, but it would go a long way to changing this. If there was a method to block all non-sandbox code on the Mac, it would be great to guard against this type of malware, even if the root escalations were still there. But I think what's really going to happen is that root's abilities are going to be reduced even more over time. So they'll be even less interesting to an attacker. And with that, Does anybody have any questions? And I will tweet out the queries to run an OS query. Like, that's the homework that I want everyone to have, is like, go run these queries and see what's vulnerable on your system, because I'm betting that at least half the Macs in this room are vulnerable to these types of attacks.
Questions? Okay, I have one question.
Yeah.
Do you think it would be a good idea for a malware author to perhaps, once they get on a system, run this query and then dynamically basically find?
Yes, so that's
it's different on each system. Right?
Yeah, so that's exactly what my sample does.
Oh, awesome.
When I was first writing it, I was like, I just had hard-coded paths, but
yeah.
Then I was like, well, why don't I just scan everything? It wasn't that hard. I wrote it in Swift. It was my first Swift app, so it's super fast. If your malware wants root and you can do this, then you should do it. Well, you shouldn't write malware, but but if you're going to and your malware needs root, like, just make it easier for your users instead of asking them to authorize it. Like, if you can't find anything vulnerable, then you can still pop it up. But
yeah, I like that approach. So, and were you also surprised by the fact that this app was able to be notarized?
Yes. Like, so really all it does, so the app, it's a simple Swift app. It has the program that actually does the malicious stuff as a string, and then it just writes that out to the file system.
Yeah.
And I mean, I don't know what notarization does at this point, but I submitted it. Maybe Apple will make it so that this kind of thing gets rejected in the future, but
that would be ideal.
Yes. I think, like, apps looking at your file system, like, that's a legitimate thing to do.
Sure. Apps
writing things to the file system, that's legitimate. So it's hard to, I think it would be hard to look at the intent of this programmatically, but it's certainly something that I would expect to not be notarized in the future.
Awesome.